will be exploring Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. What is momentum? It is a property of a moving body that the body has by virtue of its mass and velocity. We can say momentum of a body is equal to product of its mass and velocity. As momentum is directly proportional to both mass and velocity, we say more the mass, more the momentum, more the velocity, more the momentum. For a body, momentum will be zero if it is at rest, that is, if velocity is equal to zero. Let's understand it with some examples. There's a bus and a bicycle moving with the same velocity. Now, there are high chances that the bus may kill a person standing in its path. Now, why? As the bus has more mass, it has more momentum. There's a bullet thrown with hand and a bullet fired from gun of same mass. Now, what do you think? Which can kill a person? Definitely, the bullet fired from gun can kill a person because as the bullet fired from gun has more velocity, it has more momentum. So we can see from these two examples that momentum is directly proportional to both mass and velocity of a body. We know, according to Newton's second law of motion, force is directly proportional to rate of change of momentum. Now, what is the relation between force and acceleration? Let's derive. According to Newton's second law, force is directly proportional to rate of change of momentum. Now, what is change of momentum? Final momentum minus initial momentum, that is mass into final velocity minus mass into initial velocity, taking m common. Now, what is rate of change of momentum? Rate means change with respect to time. So, divide it by time. Now, what is v minus u divided by t? That is change in velocity upon time. It is acceleration. So, rate of change of momentum is equal to mass into acceleration. Now, force is directly proportional to mass into acceleration. Now, when we remove the proportionality sign, we have to put a constant. So, here it's a k. Now, here the unit of force is so chosen that value of constant k becomes 1. So, force is equal to mass into acceleration. Now, note mass should be in kg and acceleration should be in meter per second square to get force in Newton. Let's see some daily life examples where we apply Newton's second law. If you would have ever seen cricket match, how does a fielder catches a ball? Yeah, a fielder gradually pulls his hand with the moving ball while catching it. Have you ever wondered why? He is trying to increase the time during which the high velocity of the ball decreases to zero, so that the impact of force is less on his hand, that is, the ball don't hurt his hand. Now let's understand it by an example. Let's take a ball of mass 1 kg coming towards the fielder with an initial velocity of 50 meter per second. The final velocity will be 0, that is after catching. Taking formula of force as mass into acceleration. If the fielder takes 1 second to catch the ball, the force experienced by the fielder's hand will be 50 Newton. Now your minus sign indicates that it is a retarding force. Now if the fielder takes 10 seconds to catch the same ball, the force experienced will be minus 5 Newton, that is 10 times lesser than earlier. So from this we can understand that if we increase the time duration in which the fielder catches the ball, the force experienced by the fielder's hand will decrease. If you would have noticed, An athlete is provided with sand or cushioned bed during long jump. Have you ever wondered why? As they are running with a high velocity and if suddenly stopped can get hurt. So a cushioned bed or sand bed are provided to increase the time taken to stop after the jump so that the impact of force is less, that is, they don't get hurt. Second law is also used to calculate the acceleration produced when a certain force acts on a body. Now we know force is equal to mass into acceleration. If we shift mass on that side, acceleration is equal to force divided by mass. So from this formula we can see acceleration is directly proportional to force and inversely proportional to mass. So as force increases, acceleration increases, and as mass increases, acceleration decreases. Let's understand it by an example. In first case, take balls of equal masses, hit them with different forces. You will see that the one you hit with greater force will gain higher velocity. That is more acceleration. So here we can see that as force increases, acceleration increases. Now in second case, take balls of different masses. Hit them with same force. You will see that the one with smaller mass will gain higher velocity. That is more acceleration. So here we can see that as the mass decreased, acceleration increased, or we can say as mass increased, acceleration decreased. Do you know how do we actually break boards in karate? How is second law used in this? If you know the answer, comment down.